Hi, this is Richard C. I'm a math tutor here at Wyzant answering a question submitted by a student. And this is a graphing problem. We're trying to graph this curve y equals x cubed plus 9. And we're using the very most basic method, which is to plot points. And so we'll go ahead and do that. Unfortunately, when the question came through, we didn't pick up the seven ordered pairs that they're asking for, but we'll just work with something that's reasonable. So here's our XY graph, and I'll just rewrite the equation here. I like to do that because it gives me something to refer back to. So I'm going to pick 7 numbers, and I'm going to choose these numbers: -3, -2, and 1, 0, 1, 2, 3. These are not entirely arbitrary because I already know what this curve looks like. And I'm going to discuss that briefly with you at the end, after we solve this one. So -3 cubed is -27 plus 9. So that's going to be -18. -2 cubed is -8 plus 9. So that's going to be 1. And then -1 plus 9 is going to be 8. Let's see. And then 0 is going to be 9. 1 is going to be 10. 2 cubed is 8 plus 9 is 17. 3 cubed is 27 plus 9 is 36. So those are 7 values. And let's see if we can fit this. I don't know if this is going to fit on the screen, but let's try to use the graph paper feature here and see what we can do. I'm pretty sure this is not going to fit. But you know what? We'll just have to scale it a little better so that we can see it. Oops, get rid of that. It's ridiculous. Okay. That's a little less ridiculous. Okay. So hopefully I can continue this down. Have it keep going down. And I'll move it a little bit so it's not too terribly off kilter here. I don't think I'm going to be able to rotate it back. I can try, but no, I don't see a way of doing that. Okay, let's get the other axis in here. And we'll just try to get this more or less to scale. So it's not going to be a square scale, you know, because I need to do, oops. It's aggravating. There's 1 there, there's 2, and there's 3, let's say, on the x-axis, and then on going positively, and then -1, -2 here, -3 here. Okay, and we'll start plotting points, but I think we're going to have to do, you know, we're going to go up to 36 here, so maybe 5 each. So 5, 10, 15, 20, 25, 30. So it's going to be a little distorted because of the scaling requirements here to make it fit. Okay, I guess I didn't need to have the whole page all gridded out like this. Let's plot some points. -3, -18. So that's 15, 6, 15, let's see, 10, 15, 20. Yeah, so that's going to be 20, so that's going to be around here. And then -2 is going to be +1, so just barely above the axis there, the x-axis. And -1 was going to be 8, so it's going to be more like that. And so, and then at 0, it's going to be 9, slightly higher. At +1, it's going to be 10, slightly higher. For the last point at +2, it's going to be 17. 1, 2, it's going to be somewhere around there. And then at 3, it's at 36, so there. And then if we were to fill this in, you're going to see it looks kind of like a snake. And the scale has distorted the shape a little bit, but it's actually symmetric. This half of it is symmetric with this half. If you took this half and just reflected it over the x-axis, you would see it matches this half. Oh, it's partly my penmanship and partly the scale that distorts it a little bit. And that's our graph. And it's actually symmetric about this number on the y-axis, 0, 9. So that's the long way to do it. Eventually, you're going to learn the parent functions that you need to memorize. So, for example, I'll just use 2 of them here, and let me get rid of this background. So the two that are very common, y = x squared, is the mother of all parabolas, and it looks like this. And that didn't come out. It's centered on, let me do that again. Centered at the origin. And y = x cubed is another one, centered at the origin. And it's the same snake shape that we did here. So the difference here is that this x cubed is shifted up 9. So I could have sketched this immediately just by knowing the parent curve. In other words, I would have just put this up here like that, and then this would have been 0, 9 here. And that's exactly what we found on the left. It's just a lot faster to do it this way. So if you memorize your parents, you can figure out what the child looks like very quickly and draw a quick sketch. You can't make it as precise as this, but you can do a nice quick sketch. Okay, so that's it for this problem. Just continue working on this. Start to memorize your parent functions, and you'll be in good shape. Okay, see you next time. Bye-bye.